Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder of NAC Cove, coming to you live from the Mile High City in Denver, Colorado. I am joined by my awesome partner in crime, Mr. King James Stallcup, CEO of the Volt Online Academy and creator of the High Voltage Live podcast. Very honored to have you with us. Very honored to have everybody join us every week, and very honored that I get so much participation on the Myth of the Week, and I just keep coming up with more every week. I don't know what happened with the NEC for Dummies group or looking into it. It just this morning just disappeared, and I have no idea what happened. It's just the weirdest thing. I don't think that's ever happened to me.
Well,
So
it, I, I thought they usually give a warning, something. We've never even had a warning on anything. Apparently, there's somebody out there not happy with us.
I
And
guess so.
uh,
Yeah.
uh, whoever probably called in, we're going to find out, but I'm just going to tell you, we're going to keep coming stronger and stronger. And
Yes,
you
sir.
think you're going to deter us, you got another thing coming. And I'll tell you this, I've got some things that are working right now. If this goes, I can tell you it's huge. And
Yes,
you're
sir.
not going to stop that. So
Yeah.
there's going to be hundreds and hundreds of thousands of people knowing. So, you
Yeah.
know, I have an idea what might have happened, but we're going to find out. We got people looking at it right now, but uh, if if it went the way I think it did, that that tells you there we're striking some nerves.
Yeah.
Telling the truth.
Oh yeah.
But we'll
Yeah,
see.
it was really awesome that I still had so much participation. I still hit over 45,000 this week, so it was pretty awesome. I mean, I had so much participation, so many people were interested, and so many people is interested in like learning the electrical code and learning the trade and learning stuff. And so it's really awesome that we're able to kind of use our experience to bring you that every week. And it's just been a lot of fun for me. And I have a really good show lined out, and I gave James at least two really super easy questions this week. So I want him to like get back on the winning track again. So this week's Willie Quiz is gonna be easy. So I'm hooking you up, brother, this week. So
We'll find
don't
out.
don't expect me to be so nice and easy every week, but this week for sure there's at least one you should just nail right off the top of your head. So you know, it could be a little bit of a trick question, but we will see if I can fool you. And I don't think I'm gonna fool you on all of them this week, but it's a lot of fun for me to do to put this together. And so I guess let's roll the meme of the week.
Our meme of the week, yeah.
That's pretty funny.
Hell
Uh,
yeah.
it's crazy. Like every job I go to, we'll always like mess around with like the young engineers and stuff. Like they'll be, especially like in the industrial, you'll tell them all kinds of stuff that they don't know, and you can tell them good information or fake information. But I know one time we were doing this hospital, and the one of the engineers, you could tell this kid was just out of college, and he comes through, and I says, "Oh yeah, it's polite, when you're in this hospital that when you go walk through every door, you knock on it first, and okay." And he's going over there knocking on every door. We're just
Oh
over
yeah.
there rolling, laughing. And it was funny. We're like all, oh, good job, good job. We're all egging him on. Oh yeah, man, everyone. And it was just we're just back there just busting laughing. But I'm sure he realized that we were just messing with him. But
Well,
usually the electricians are the smarter of the trades on there, so that we can mess with people and make them believe
well,
stuff.
I
And
can tell you back in the 1960s, and I heard this story from Dad. He said that they went and ate this coffee shop. They were working downtown on one of the high rises, and they'd always went to this coffee shop. Everything was pretty much a coffee shop back then. And they go in there and they were eating lunch, and said this plumber really liked this waitress, and the waitress liked Dad, but Dad's married. He just being nice to her. And he said that damn plumber told him, he goes, yeah, he goes, you electricians just think y'all are better than everybody else. And he said he reached across there and hit Dad across the shoulder, knocked him forward. Well, Dad's journeyman was Charlie Winchell. Now, Charlie Winchell is a Golden State champion in boxing and Golden Gloves. And Dad said he reached across there and he just come across and hit him right in the shoulder, just knocked him across the room. He goes,
oh, wow.
He goes, that doesn't feel good, does he? He goes, don't you touch my apprentice, you understand? And Dad said there, but Dad said, yeah. He goes, even back then, I never forgot that. The guy saying, y'all electricians think y'all are better than everybody else.
That's funny.
That's why I started laughing at the meme, because I started thinking about that story.
Yeah.
Oh,
it's so true to life, and I love all the people posting the memes over and all the different groups, and I really appreciate all the participation. Like I say, I'm gonna try to get a learning group back up and going again, and so I can kind of get all my different stuff that we've learned kind of compiled, because that's kind of what I loved so much about the NEC for Dummies group is we were constantly just learning all this new stuff, and that's kind of where this myth comes from. And like I just learned this when your dad did that last podcast on, and it just blew me away, because I mean, honestly, it really makes a lot of sense just hearing it from your dad and hearing how he explained it.
Mm-hmm.
And it is unfortunate that a lot of people are pretty much wrong on that, but it is what it is.
We're going to cover it, so let's roll the myth of the week and get into it.
Right. Roll it.
It's time for Myth of the Week.
All right, so this one comes, we kind of did touched a little bit on this with the concrete encased electrode, and one of my myths that we did before. I just put this picture up there because it was so funny. When I saw it, I was like, oh man, I gotta put that up there. Like, there's, like, just because people run stuff like that, like, I wouldn't. I don't see inspectors really passing that kind of stuff when you have exceeding 5 times the bend radius, and just the way it's stapled, it could possibly damage the conductor stuff. Mm-hmm. So I don't think that's a really awesome install. And then the service conductors coming in, or maybe the feeder conductors coming in, look horrible. They could have squared them off or did something, and just have them go all the way over and just droop in. Just looks terrible.
Well, you would think they would bend those a little more straight up, because you can see it pulling in that terminal.
Oh yeah, and so that's really not what this myth's about this week. So I really did appreciate all the comments that I got this week. It was really awesome to discuss it, argue it, talk about it, and just get everybody's take on it. I actually agreed with a lot of people that said they just run number 4 to everything. That's typically what I do. Like when I do a 200 amp service, I'll actually hit the cold water bond. I'll come out, I'll hit the ground, I'll hit the UFER, I'll hit whatever, and then I'll hit the ground. If I have a ground rod, I usually do 2 ground rods, and then I hit the panel. But it's typically, it's easier to just buy one conductor, All right, David Englehart. Awesome. Yeah, and that's true. It's not required to be larger than number 6. So where this comes in, where we learned from Senior in the podcast that he did, basically the reason why they took made electrodes out of the table was because people were running too large a conductor to them, and they weren't making good connections. So I can just imagine if people could picture running like a 3/0 to ground rod, that wouldn't make good sense. The other thing we learned in that podcast was that the table is based off of a multiplier that comes from 250-102C1, and then that's how they got the ratio of what the grounding electrode conductor ratio is supposed to be to the ungrounded conductor on the service entrance. Well, the made electrodes were tested and sized based off that testing, not off the table. So that was one of the things for me that was really, it opened my eyes a lot. And I don't know, I imagine you could probably explain it a little bit better than me.
That wasn't table 250-102C1. It was table 250-122 that it is now. And they did a multiplier 0.189 when they were doing all that sizing. Now, right. One of the things I want to point out.
I don't think that was 12.5%, David.
Over there, when you're getting into the larger conductors where you're over 1,100 kc mils at 12.5%. And that's what he's talking about. But when they were doing the table, at that time was table 250-94, which is now table 250-66, and now you also have another table 250-102C1 that's similar, almost identical except for the headings. That's how they use a multiplier based on the overcurrent protection devices to determine those size conductors. Okay.
Right.
And I'm going to show a couple of things here and go a little more in depth on this. And I put a couple of things here, and I just wanted to start with in the 2023 250.66 because they made some changes. And they tell you right in the heading, it says the size of the grounding electrode conductor and bonding jumpers for connection to grounding electrodes shall not be smaller than given in the table, okay? Then it says, except as permitted in 250.66A through C. What they're telling you here is they don't want the table being used, period.
Yep.
Okay? And when you look at A and you get the rod and pipe and plate electrode, you need a number 6, okay? Copper. Then you go to concrete encased electrode, it's a number 4. Copper, yep. And then to a ground ring, it's a number 2, which you'll pick up in 250.52A4. Okay, so yep. I'm just putting that out there now, and I'm going to prove this point in a minute based on substantiations from the code making panel that said and I'm going to show 2, but the main one I'm going to show is a connection to a concrete encased electrode because somebody submitted a proposal and said they could go smaller. And the code making panel specifically stated that even a number 6 was considered too small for the concrete encased electrode. And that was based on all the testing that was done. Okay.
Well, yeah. And that's why I wrote in my myth the sole connection, because you are permitted to share electrodes.
Sure you are.
So, and like if you have a certain size, then you're permitted to share building steel and ground rod. You know, I mean, your building steel is going to be way larger than whatever your ground rod is going to be.
It depends on how it's set up, if it's looped or not. And most of the time what they do, they come up, hit a terminal bar, and everything comes up whatever size it is. And then from there, whatever the largest is goes to the panel board or service equipment. Okay?
Okay.
Now, let's take a journey through time. Okay? Now, this is a 1981 NEC. And this is when they pretty much, when you look at the 78, you're going to get some of the same stuff. But this is where it really started. And this is where they talked about the size of the grounding electrode conductors. And if you notice here, when you get to exception 1, we'll just do grounded systems. Exception 2 is ungrounded. It says it's pretty much the same thing. But what it tells you here, it says when connected to a made electrodes, and then it says as in 250-83C and D. When you go pick those up, that was rod and pipe electrodes and plate electrodes. Okay. Now, what you're going to see, it was at this point where we used to have made electrodes. That is no longer in there. You're not going to hear made electrodes anymore. Okay.
Right.
And when we had Dad on, he was trying to explain this. And, I think, who was it? I can't remember. They were going, yeah, but you can still do it. He said, well, Lloyd Mills. He goes, let me ask you this, Lloyd. He goes, so you're saying if I come in your jurisdiction, you're going to pass if I put something smaller than a number 4 to a concrete encased electrode? He goes, well, no, we're not going to pass that. And he goes, but you're saying it's okay. It just goes to show some people just don't want to admit they're wrong, even when you have the documentation here to show what the intent was of the code making panel. Now, one other thing I want to point out, I want you to look at the language here. It says, shall not be required to be larger than. Okay? So even then, they had this language and they're telling you a number 6. Okay?
Right.
Now, let's move forward. Now we go to the 1984, and look what we start seeing. We get something different here. Okay? You're going to see they're going to have 250-83C and D, which we just looked at. Then they come in and they hit 250.81C, where they talk about to the concrete encased electrode, and then 250.81D as you go to a ground ring. And at this point, we still are calling the ground rod and pipe and plate as a made electrode. Do you see that?
Yep.
Okay. So this way, nobody can say I'm making anything up here. I'm showing you exactly the wording that was in the code at the time. So the other thing I'll point out one more time, it doesn't matter if I go to a ground rod, concrete encased electrode, ground ring, it still says shall not be required to be larger than. You see that?
Right.
In all 3 of them. Okay.
Right.
Now, look at this. This was exception 1 and 2. And they were doing editorial corrections when this took place, and they were talking about 250.83 no longer made electrodes only. So they unanimously voted that. Okay.
Right.
And they basically were saying we now have C and D, which is concrete encased electrodes and a ground ring. Concrete encased and a ground ring. So there's no longer made electrodes just in that section, and that was voted unanimously affirmative. Then they come down and they talked about the so in the 3rd line. It says the present requirement implies that if a made electrode is the only grounding electrode, the electrode conductor may be a number 6 wire, number 4 aluminum. But if a made electrode is supplementary per 250.81A, the grounding electrode shall be per table 250-94. Now, this is where a problem is, because they're trying to say that I can size to a supplementary based on the table. And it says, I do not see the justification for requirement since a made electrode is currently limiting under either condition. And then they rejected it. And they said, due to the reason, under some conditions, this will permit made electrodes to be connected by what? An undersized conductor.
Yep. So
you got like 100 amp panel board back that time. You could have actually done that and went to a what? Number 8. They are not going to allow that. So that's why they're telling you here, under some conditions, this could happen. So even if I go to the supplementary grounding electrode, they're telling you here that you still had to run over number 6 to it. Okay? Now, let's take a step further.
Yeah, and David has a good point too. That could have had something to do with
that could too, but this is going to clear it right here. Now, if you look here, it said add after section 250A3C or D or section 250.81C. Now, I want to read the substantiation. I'm going to show you the panel rejects what he says here. It says, in the revisions of the 1975 for 1978, concrete encased electrodes were relocated from 250.83A to 81C, and the rebar was added. Section 250.94, exceptions 1 and 2, then changed from section 250.83 to 250.83C and D and the 1981 NEC. Okay? Now, I already looked at the 81. Okay, so they're doing this on 84. And he says, it appears that the concrete encased electrode or UFR ground electrode was recognized as meeting the criteria for the exception during 1975 NEC, but lost that recognition in the 1978. Okay, and that's why I was reading that other stuff. And then he says, and remained so in 1981. Data submitted by Proposal 61 for 1974, look how far they're going back to try to get this passed. Preprint indicates that the expected resistance of the UFR is such that number 6 copper would be more than adequate as the grounding electroconductor. Now, this is going back and they're telling you that they did the testing, the data was submitted in order to say that this number 6 was adequate for this, okay?
Right.
Then he says, perhaps it was an oversight that the concrete encased electrode was relocated without being relisted in these exceptions. There appears to be adequate data to qualify for the exception. In general, data indicates that the resistance of rods in place may be expected to be less than that of the concrete encased electrode. And then they rejected what he was saying here. And what they said was the proposal would permit concrete encased electrodes to be connected by a number 6 copper conductor, which is considered to be too small. And they send you back to the proposal that was made in conjunction with this, and they voted unanimously affirmative. And in summary, they told you the panel agreed unanimously affirmative that the number 6 to the concrete encased electrode would be considered too small.
Yep.
Now, I didn't make any of this up. This is exactly, you can go back and you can look at 5-163 and you'll see the panel specifically stated. And if you notice, the language didn't change. So if the language didn't change, how am I allowed to go smaller than what is listed there for the ground rod or the concrete encased electrode when they're telling you here that it's considered too small?
Well,
Okay?
yeah, and it's considered too small based on the testing, right?
That's right. That's the data that was submitted. And
so you're saying that those made electrodes were tested with those size conductors and not just like all tested with number 8 and said it was adequate.
Yeah, they said it had to be that size to be adequate. And that's what gets me, because he states that the number 6 would be more than adequate, but yet he wants to go lower. That makes no sense. That he's telling you there the testing and data said for that a number 6 was more than adequate, okay? But yet the data suggested they move up one to make sure it took care of the resistance, because they wanted to make sure that they connected to a number 4, because a number 4 was the concrete encased electrode.
True.
Okay?
Yeah.
Now, and that pretty much takes care of it showing what was required by the code making panel. Now, this isn't my opinion. I'm not giving you what I think it should be. Personally, I don't care if you go low or not. But if we're going to go by what the code making panel says and what they determine for the sizing of the grounding electrode conductors, you can't go smaller. Now, I made a proposal for the 2026, and I made a proposal to take out the text except as permitted in 250.66A through C and delete A through C. Because if you can use the table, then there's no need to have that. You just go ahead and put the size of the grounding electrode over there in your grounding electrodes and just say the conductor has to be at least number 4 there, and you can go smaller. And I don't think they're going to do that. Then I submitted the proposals of the data that was submitted and the testing. And I said, this is what the previous code making panel stated. If you disagree with this, then you need to make some changes. So we'll see what happens.
Well, awesome. Everyone that said true, you are correct. Like I say, we didn't find one single inspector that was willing to pass anything smaller than what the made electrodes minimum was. So,
heck no, they're not.
You know, think that's a good thing.
All right, you ready for the topic? I want to.
Awesome.
This week, I'm going to finish up part 2 of the arc flash risk assessment. So,
all right.
I took and pulled a bunch of tables out and everything to explain the rest of this. So let me go ahead and cue it up. All right, let's get cooking on this. All right, so this week we're going to look at part 2 of the arc flash risk assessment. And where we're going to start here, just so we tie all this in, we're going to start with the arc flash boundary. We looked at this last week, but it tells you that this arc flash distance shall be the distance at which the incident energy equals 1.2 cal centimeter square. And then it tells you when you're estimating the arc flash boundary, it tells you to go look at Annex D. And then if you're applying the tables to get that value or to get that arc flash boundary, they tell you if you're doing AC systems to look at table 130.C15A, and DC systems is table 130.7C15B. Okay.
Hey, question for you really quick.
Mm-hmm.
So, just for all the dummies in the audience like me, is there any correlation between that arc flash boundary and the working clearance?
No. Nothing.
Okay.
The working clearance is specific to the NEC as an installation. And the reason you have that in there, it's not for arc flash boundary. They give you them clearance distances in order to protect you from a shock. So in other words, you're not able where you're standing somewhere and reach behind you and create a touch and step potential. That's what it's for. And I know who said that in one of his videos, and he was wrong, and I called him out on it, and he didn't even reply. So, but anyway, now here's a sample calculation here, and this is where we're showing one that's made on a 4160 volt bus. And when you look at this calculation is going to be different than when we get into other calculations, which we're going to look at here in a second. But I just wanted to show this because we've actually had people call us on how to do this before they had the software that was calculating it, and we would go through and explain all this. And basically you're going to have your transformer there, and it's going to talk about the MVA of it, and you're going to see it's rated at 10 MVA, and then you got an impedance of 5.5%. And then you also need to know, which I said, there's always 2 pieces of information you need to know, but one of them definitely you need to know what? The clearing time. All right?
Yep. And just for all the people out there to understand too, 4160 volt is considered medium voltage. So we kind of did our high voltage live as a joke because we as electricians, we rarely work on what is considered high voltage or even medium voltage. I have worked on some medium voltage, but just something to keep in mind.
Sure. Now, the calculation you're going to do here to get what the short circuit current is, you're going to need to know that MVA base. And of course, that's 10. And then it's going to be multiplied by 10 to the upper power 6, and then it'll be divided by your voltage times 1.732 for three-phase, and then you got a common denominator you use at 100, and then you multiply it's divided by the impedance. And then what you're going to do, you're going to take that impedance and that voltage, multiply it, and then you'll divide it in to that base. And when you perform this calculation, it's going to give you 25,000 amperes. Okay. So that's going to be my short circuit current. Now, this is the next part of this, because now you're going to calculate what the power is in the arc, and then we're going to calculate the second degree burn distance. And then I'll show you a different alternative method that you can also use that's much easier to do the calculation than doing that. See, the one we're doing right now is getting you pretty exact. The other one is more like a conservative calculation, okay? So when you're determining the power, you're going to have 1.732, that's for three-phase, times 4160 volts, times 25,000 for the short circuit current, multiplied by 10 to the lower power 6, and then you'll multiply that by 0.707, which will be squared, and that'll give you 91. Okay, that's going to be your power right there. Now, in order to do the second degree burn, now what you're going to do, 2.65 is a constant, and you're going to see I'm going to have the exact same thing going across except for one portion there. I'm going to multiply by 0.1, and then you'll take it at a half to the upper power, and that's going to give you 6.9 for your cal rating. Or you can, I'm sorry, not cal rating, but your distance is going to give you 6.9 for your arc flash boundary. Just round up and say it's 7 foot. Now, if you want to do it the easy way, then what you could do is just take 53, what's a constant, time that transformer base, which is 10, and multiply it by 0.1, and you'll see you have half the upper power, and that'll give you 7.28 foot. And that's
and is that your restricted approach boundary, or is that your?
No, that's your arc flash boundary there.
Okay.
Yeah, all that right there is two different ways to calculate that to get your arc flash boundary when you're dealing with higher voltages.
So that arc flash boundary, how does that relate with the limited approach and the restricted approach?
The limited approach and restricted approach, what you're going to get into, that's in 130.4 D, A, and B. And that's where you go in, and that's for shock protection. And for shock, and that's what I'm saying. That's going to, at the very minimum, that's going to be your barricade. So now, once I do the calculation for the arc flash, if that arc flash exceeds what that limited approach boundary is, then that becomes your new boundary and your new barricade.
Okay, gotcha.
Okay.
So this is the overall limited approach boundary combined with the restricted approach boundary.
Yeah, the limited is just to protect personnel that are unqualified from entering the area. When you're in the restricted, we consider that the same as you're going to be working on it. So there's no inadvertent movements or nothing within that area.
So if you're in that restricted approach boundary, then you're actually dressed for this calorie rating based on this footage, right?
Oh, sure. Once you go inside the arc flash boundary, you got to be suited up, period.
Gotcha.
Okay,
gotcha.
And you know, I brought this up before. When you look at the 70 document, you'll notice we don't talk about any specific person. Basically, what we're telling you, anybody that enters that area has to be suited up. So if you're an inspector, an engineer, or something that's going there looking, you got to suit up if it's energized.
Temporary. Well, the reason I was asking, because 7.25 feet is pretty far. I mean, like that's a massive event. We call that an unintended rapid disassembly in the field when you're involved in these arc flash events. And you know, like 7 foot, that's far. That's shooting some.
And these are calculations that have been done there by IEEE and labs and stuff where they've actually done the testing and everything and figured out these calculations in order to determine what these distances are going to be.
Gotcha.
Okay. Now,
all right.
here's a good one. Now, these are going to be basic stuff like you're going to see all the time, where you're doing arc and open air. The stuff we were just looking at is where you're getting into the switch gear that's coming in. Okay, and you've got
so that's basically what we call arc in a box.
Yeah. Now, when you look at this, you're going to have some things that are set up here. You'll have a constant, which is 5271. Then you're going to have DA, and that's going to be your distance from the arc electrodes. Now, normally, most of the stuff you're going to work on is going to be from the end of your hand up to your shoulder, your arm length. That's going to be an 18-inch distance. Okay? That's just typical. All right? Now, you could be...
Oh, we got Jason. Jason, back in the house. Awesome, sir.
Hey, thank you for the nice comments. Yeah, thank you for the nice comments the other day. But when you're racking something in or out, that distance can be like 24 inches. You see what I'm saying? That will change. Yeah. So you have to take that in consideration. And then I said, when we get over and we look at the tables in a little bit, I said, when you're doing the tables and you're doing these calculations, I said, there's two things you need. You need to know what the clearing time is. In other words, how fast is it going to clear in seconds for that arc duration? And you also need to know what? The short circuit current. Now, we were at the service. We calculated that in the last one. Now we're going down to a lower level here. Okay?
Okay.
So here's an example calculation right below it. It says, calculate the maximum open arc incident energy, and then we're going to tell you that the distance from the arc electrode is 18 inches, the clearing time is 0.2 seconds, and then we're going to tell you the short circuit current here, or the available fault current, whatever you want to call it, is 20 Ka. All right? Mm-hmm. Then all you're going to do, you're going to insert these values, and then it's going to tell you that your cal rating right here for this arc is 5.098 cal.
Okay.
Okay. So now you know you have to put on at least, in this case, I'd say I'm putting on at least 6 cal.
Yeah.
Okay.
Absolutely.
All right. Now, watch this. Now you go to an arc in a cubic box. Now they're going to tell you this is where the arc is going to be contained inside. In other words, it's going to produce more of an arc because it can't escape into free air. So they tell you what is considered a cubic box. This is 20 inches on each side, and it's open on one end. Okay? So you'll look here, E and B. They'll tell you that's the maximum 20-inch cubic box. Then they've got your DB, which is the distance from the electrodes. You got your TA, which is your arc in seconds. And then your F, of course, is your short circuit current. All right? Now, here's the calculation. You'll see here. Now, what I want to point out, let me go back here because I want you to see this. Now, you'll look here. We got my distance from the electrodes, 18 inches, my clearing time's 0.2, and my short circuit current's 20 Ka. Okay? We just did that for arc and open air and got 5.098 cal. Now watch this. I'm going to use the exact same values here, plug these into the calculation, and because it's more contained and it can't get out into the free air as quick, now you're going to have at least 8.144 cal.
Right. One thing that blew me away about when Mike Barr did his open air thing was that they were energizing 80,000 volt switches with 2 cal on.
Yeah, but there's a ton of open air up there, but and they're energizing from down below. All they're going to get is some little sparks on them.
Yeah, and that was the other time when I realized that they had a difference between arc rated and burn rated and flame rated.
Flame rated.
Because they have flame rated and arc rated. So that was interesting. I learned that. So shout out to you, Mike Barr. That was awesome.
Well, I'll tell you, we actually learned that from Mike. And when we were at the 70E meeting, this is many, many, many years ago, Dad brought that up and he said, flame rated's not the same as arc rated. And they were arguing with it. And they asked we had one of the manufacturers, Oberon, on there, and they said, no, James is right. Flame rated's not arc rated. And they were like, you're kidding. But people didn't know. And we learned that from working with Mike in doing the OSHA high voltage publication we have.
Right. Yep. Yeah, Mike's an awesome dude. So hope you're out there, Mike. Big shout out. We love learning from you, sir.
Yeah, Mike's a great guy. He we've had dinner with him many times. He's just a good, genuine guy. And I'll say this, he knows that utility stuff. He is top in his field on that. And if we ever, we've actually done jobs before, and we've asked him how to do certain things because they had us come out as the expert. And he said, oh, yeah, do this, this, and this, and told us what to do. We didn't have no problem with it after that. But
well, and I did like the little thing that he had. It was a little mock-up where he had like, okay, if you do this and you ground like this, you have dead linemen.
That's right.
That was really cool. I thought that was awesome.
And he was showing, they said that you can do this. He goes, let me show you. You can't.
Yeah. Yeah, that was awesome. That was really cool.
Okay, now check this out. Now, this is where you get into F, and I covered this a little bit last week. I didn't get in depth with it, but it tells you have the following methods that can be used here for the selection of your arc flash PPE. And it says you can take and do the incident energy analysis method, which is what we just did for arc in open air and in a cubic box. And then it tells you that I can select the PPE based on what? 130.5 G. And if I'm using the arc flash PPE category method, I can use what? 130.7 C15. I'm going to show the difference in these. Now, I will say this. When you look at 130.7 C15, there's a lot of conservative values that are built in there, and you can never exceed the parameters that are for each one of those specific pieces of equipment. And if you exceed that, then you have to take and do the incident energy analysis method. Okay?
Gotcha.
And then they put down below, you can use either, but not both methods. And I'll just leave it at that. Okay?
Right.
Now, if you look at this right here, this is where you get into table 130.5 G. Now, we used to have this over in Annex H at one time, and before that, we didn't even have the table, and people were complaining. So we put a table back there where you could go in and select your PPE. Now, what we tell you is once you get over 1.2 cal, that's what's considered a curable burn, a second-degree burn, and it says up to and including 12 cal, this is what we tell you need to have.
Gotcha.
To protect yourself. Now, you'll see some things in there, SR. That means selections required between those. Then you have AN. That's as needed. Okay? Now, check this out. Now, once you get over 12, well, let's just look at one thing here, for example. It says, I'll go down to the third selected item. It says up to 12 cal. It says arc-rated face shield and arc-rated balaclava, or you need to wear an arc flash suit hood. Okay? One of those will work. All right? Now, watch this. Now, as soon as I get up above 12 cal, look, you don't get that option. They tell you have to wear an arc flash suit hood, period.
So what was that one? Didn't we find one where there was a certain cal rating that you had to wear a face shield? Like, wasn't it 4 cal?
Well, you're always going to put the face shield on. The one thing they had to come in and correct was putting on the sock hood, the balaclava, because you had to protect the ears and the back of your neck.
Gotcha.
But the face shield was always there. Okay?
Was that at 4 cal? Or
Yeah.
what was that threshold?
When you get back here, you start looking at this. It says an arc-rated face shield. This is when you're doing it based on the calculated method. Okay.
Okay.
Now we're going to look a little different when we get into the hazard risk category. But here, if you do the calculation method, once you're over 1.2 cal, you've got to have an arc-rated face shield.
Okay, gotcha.
Okay?
All right, now I'll get info.
Oh yeah, that's why we do this. All right. Now, yeah, once you're in the arc flash boundary, your exposure, you got to suit up. That's correct. Now, this is where you get into the arc flash PPE categories. Now, I'm just gonna make one up here. All right. Let's just say that I'm working on a panel board or some other type of equipment that's greater than 240 volts. We'll just say it is 277. All right. Now, if you look here, there's some parameters right below this. Now, it says a maximum of 25 Ka available fault current. If you have 30 Ka, you cannot use this table. The hazard risk category methods, it's over. Okay. You've got to meet that or lower. Also, the clearing time has to be 2 cycles or 0.03 seconds fault clearing time, and a maximum working distance of 18 inches. If you don't meet any of those, you cannot take and use this table right here.
Gotcha.
Okay? Now, when I come over and I look over here, I was looking at the second one, and you'll see I come across, it says the hazard risk category was a 2, and the arc flash boundary had to be at least 3 foot. Now, in this case, if I took and I did my limited approach boundary, now I'm at 3.5 foot. The 3.5 foot exceeds the 3 foot, right?
Yes, sir.
Okay, so that's going to be your very minimum based on shock protection. Now, let's go back and look at another.
And so is that where it actually correlates with the NEC for the working clearance?
Sure.
Okay. Because of the voltage and everything in the table.
Yeah, you'll see there. I mean, they're a little bit different because it depends on, what the working clearance is in front of it. Because
Gotcha.
you could have equipment opposite of it. Now you're looking at C. Yeah.
That would be condition 3, right?
That's right.
Okay, gotcha.
Now, let's just do the next one. Let's just look at a 600 volt motor control center, one right underneath it. It says a maximum of 65 Ka available fault current. It's got a clearing 0.03 seconds or 2 cycles, and a maximum working distance of 18 inches. Now, come over here, come across. It tells you I'm still in a hazard risk category, but my arc flash boundary just increased to 5 foot.
Gotcha.
See? So you got to look at all of this. And this is where you get it. Now, if I go back and let's do something a little bit different, go down to the next one, and I want you to see I'm doing a 600 volt class motor control center, but look at the clearing time, 20 cycles, 0.33 seconds.
Woo.
Okay.
Wow.
Now, if that happens, look, you automatically went to hazard risk category 4, and now the arc flash boundary kicks out to 14 foot.
Ooh, 20 cycles, you're basically arc welding.
Mm-hmm. But you can see, I'm just moving through everything, very consistent, depending on what I'm going to do and based on the tasks that I'm going to do. And based on that, I just look at my parameters. If I meet those, then I could use this table if I want. Or I could do the calculation method. Either way is going to work, but you can't use both. All right? Now,
I like it.
Look at this. Now, if I'm in a hazard risk category 1, this is an arc rating up to what? 4 cal. Okay? They're going to tell you here, you're going to see all I have to wear here is safety glasses or safety goggles. You don't see a face shield. You see that?
Yep.
Okay? Now, if I'm looking up above it, that's just protective equipment. Now look up. It says an arc rated face shield or what? A suit hood. Now, A lot of people will take and go down and look at the protective equipment and won't look at the arc rated stuff here. Even at up to 4 cal, I have to wear what? A face shield.
So
Okay.
that suit hood is the balaclava.
Uh, well, the balaclava is not the flash suit hood. That just goes all the way over you. The balaclava fits around you, and you got a little open around the eyes that you see out of with your glasses.
Okay, gotcha.
That's a balaclava.
Okay.
Or sock cap, hood, whatever you want to call it, but most people call it a balaclava. All right?
Okay, 10 points.
Now, for whoever has said that before, that I don't have to wear a face shield, I'm proving to you right here you have to in each one of these. Okay? Now, once I get up to hazard risk category 2, this is up to 8 cal. And you're going to see an arc flash suit hood or arc rated face shield and arc rated balaclava. And then you go down, you do your selection. Then I go up to 25 cal, 8 to 25 cal for a hazard risk category 3. And look, you just start seeing it change. They start wanting more stuff on to protect yourself. And then, of course, the last one is a hazard risk category 4, which goes up to 40 cal. Now, I'm going to state something here, and people are not going to like what I say, but I'm telling you, you can do this. All right? Now,
that never happens.
There was this thing going around there at one time, and they said you can never work on anything over 40 cal. 70E does not tell you that. The 40 cal where people were making this assumption was based on the hazard risk category with a lot of conservative values built in here. But nowhere in 70E does it say I can't work over 40 cal. Matter of fact, I've seen 100 cal suits. All right? And the reason is because sometimes they have to do it. I would not do it. Matter of fact, anything that's up to 25 cows, probably I don't want to get in there. Okay?
Yeah,
but
I agree. 100 cal is, dude, that's a lot of energy.
But let me explain. You can have the suit on that can protect you with the break open threads and everything, but there's something else you're going to have to worry about. You're going to have to worry about pressure. And the pressure of the explosion, it'll blow you across the room. Okay, that's what's going to hurt you. It's not so much that the suit won't protect you; it's the pressure from the blast that'll hurt you. And then you got to worry about shrapnel and everything else that can come off of there that could be hitting you also because of how much of pressure it has from that blast. So
they showed one video where the disconnect, there was a dummy in there, but the disconnect cover went and ripped the dummy's arm off.
Sure it did.
You know, so that's a lot of.
That's why I'm saying there's a lot of pressure there. But I'm just telling you, there's nowhere in 70E that says you can't work over 40 cal. The only place it states that is if you're using the table method.
Right. Okay.
Now, and that doesn't, but I want to, yeah, that's good. Okay. But that breaks down how to go through the tables and understand how to use the calculation method and how to use the table method. Okay?
Nice. No, good job on that. There's a lot of people that are interested from a safety aspect, and so I'm glad that we're able to kind of cross these boundaries and, get some other people involved in electrical safety and understanding it. And I really love this. I love when the safety guys argue with people. To me, that's awesome. For example, one of the superintendents said, I can't have stickers on my hard hat. And I was like, really? He goes, oh yeah, in orientation they said you can't have stickers on your hard hat. I'm like, well, how do you put your training stickers on there? How do you do this? How do you do that? He's like, well, I don't know. I guess something with the glue messes up your hard hat. Oh, and it was funny because the safety guy was like, oh, yep, that's 100% because he actually does his safety orientation stuff where you get your trainings and you could just scan a QR code on your hard hat sticker and it'll tell you all the trainings you have.
Mm-hmm.
So if you're forklift certified, lift certified, all these different certifications, they could just go up and QR scan your hard hat and then tell that you're able to be on that forklift. So
Sure.
I thought that was really cool, and I thought that was a good way of doing it.
Yeah. All right, you ready for your tool of the week? I don't remember what you did. Well, about to find out.
It's the DeWalt 3-speed.
Oh, multi-tool. Okay.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, so I noticed. What's that?
I was going, yeah, tool of the week.
I know. This is a new tool release from DeWalt, and it's actually a 3-speed multi-tool. I have done reviews on the DeWalt multi-tools in the past, and I am very fond of them, especially like the battery life lasting. The XR is probably one of the best lines that DeWalt's ever really come out with. They take the regular batteries, and you can run up to, I think they have 9 amp hour batteries for these, which you don't really need. I usually run the 5 amp hour batteries, but these things are really nice. You could get attachments for these where you could cut ceiling tiles and you could cut holes in the wall. Like you could just cut your cut-in box in with one of these, and they have the exact die that is the shape of like your cut-in box, and then you just put that in your multi-tool, and then you just bam, zip it right through. They're super awesome. I can't rave enough about how awesome that is to cut in a box. The one thing you do have to watch out for, apprentices out there, if you're doing cut-ins in the wall, you're gonna probably want to put your drywall saw in there and make sure that you're clearing the stud, because I've had times before where apprentices will just nail one right on the middle of the stud, and then you have a big patch that you have to do. So you have to watch out for that. But all in all, this just came out. I think it's only about 2 weeks old. I really like it. I haven't used it personally yet, but I really like the fact of the 3 speeds, because just like I was saying about, cutting something right on the middle of a stud, if you have that slower speed, you could kind of go in there and make a few holes with your drywall saw and figure out where the stud's at, and then you could just kind of go in there slow and not just rip drywall out of the frame and stuff like that. Have maybe hit something that messes stuff up. And then a lot of the reason I like the lower speed too is it's easier to do ceiling tiles. So when you're cutting ceiling tiles, it's nice to have that lower speed where it goes in there, it cuts, and it doesn't just rip the ceiling tile, because we went through quite a few ceiling tiles in the past from just that high speed and not being able to control the trigger. So if you're just able to set the gate on like a lower speed, then it makes it a nice, more controlled cut, and works really good. So this is my tool of the week, and I am a
Awesome.
DeWalt fan, as everyone knows, Yellow Decker. So here's what it is. But we had a really lot of fun with the question of the week. I think you're really gonna like this. I might actually get you on this one. It was pretty good, but I know last week was like so easy that maybe this week might maybe seem easier or harder. But I'm trying to make them easy. I want you to just nail them every time, first try. So
I like the question of the week much better than the Willie Quiz.
Yeah, I think you got one wrong so far, but and you didn't even really get it wrong. But
with the section of equipment, so this is 225. I think that's 225.4, and that's B 10 foot.
Ding, 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 ding. Nailed it. Once again, I cannot fool the master on code.
Was that the right section? 220.
Yes, sir.
Point,
Yep.
225.4.
Yes,
I know.
sir.
I knew it was 3 or 4, but I thought it was 4.
Yeah,
I hadn't
think
looked
you
at
got
that in a long time. That was one I had. I knew the
I-
answer, but I didn't remember the exact section.
It's rare that I have to bring my code book in and try to fool you with my code book, but it's all good. You're almost perfect on the code question of the week. So
Well, that one I actually answered it right the first time. I said, I think didn't they change that? I couldn't remember. It's been, it's just one I just didn't deal with that much. So.
There's ones that I got wrong on the death match that I'm like kicking myself, like, why did I get that wrong? So it's just when you're in that heat of the moment and stuff. So
Well, if I had my code book here, I would have answered it correctly.
well, keep in mind, this Willie quiz, I gave you a bunch of freebies on this one. So this one this is easy. This one's easy. You'll get this one easy. It's fire protection this week.
All right, let's roll it.
All right, so welcome to the easiest Willie quiz that we have had all year, so that James could finally catch up. He is 2-15, and he's getting ready for a easy victory
3 more.
tonight. So this one, all of these come from nfpa.org. So if you guys have any questions on where I get these facts from, they come directly from NFPA, so there shouldn't be anything wrong, but I try to copy their stuff word for word. Okay, so this question number 1, the NFPA publishes blank amount of codes and standards intended to minimize the possibility and effects of fire and other risks. Is it A, slightly less than 300, B, exactly 300, or C, over 300? Good luck, everyone. Alright, so far we don't have any answers in the chat, James, so nobody is copying your answers, so you'll be able to just
Well, this is
throw
an
one out.
interesting one because they go up quite high, but there's a lot of open in between there. And then you get like to 70 and there will be B, C, and D, and all that.
Mhm.
I'm
Well,
I'm
the reason
gonna
when I
say-
thought
I'm going
I thought of this because of what is your ones you talk about? 490.
496, 497, and 499.
All right, so
I'm going less, slightly less
all right.
than 300.
That is a really good answer, and you came really close to nailing this one. But if you were gonna pick between B and C,
Is
what
it
would you
exactly 300?
say? I was trying to get you on that one, but it is actually over 300. So, Facebook user got it at the last second. It is C, over 300. So, we got Facebook user with the correct answer. Man, I can't believe I got you on that one because it says in NFPA, it doesn't say the exact number. It just says over 300,
Yeah.
And I just thought that was weird because I was like, man, why didn't they say the exact number of publications they have? You know?
Well, when I was looking at it, I was thinking, I know there's a lot of gap in between all those standards, and then you
Yeah.
get some that are multiple. And I knew the number went up pretty high, but I knew there was a lot of gaps in there. That's why I was thinking it might be less than 300.
Oh, boom! Ultimate trick question, man. Boom, gotcha.
Okay, let's go to the next one.
All right. So, we run into this on the job site from time to time. We actually argue this quite a bit. What is the minimum distance a smoke detector can be placed from a wall when they are ceiling mounted? So how close to the wall can they be? Is it A, 36 inches, B, 12 inches, C, 6 inches, D, 4 inches, or E, 0 inches?
I know the answer to this one.
All right, good luck, everyone.
Here we go. All right, I'm gonna wait for some to answer here because I know this one.
All
I'm
right,
getting
so
this one. I'm getting this one.
we have David Englehart, E, 0 inches. Lock it in at E. 0 inches as David Englehart's answer. All right, so James knows it. I mean, we could give you some extra time if you want.
It's E, 0 inches.
All right, so
Just say it's right. You know it's right.
if James and David Englehart have a correct answer, we have 3 good answers tonight with E, 0 inches. I'm so glad everyone learned that from me. I will bring out the code reference because a lot of my apprentices were saying it was 6. So.
I knew that one because we talked about that before. I was like, oh, I'm not missing this one. Okay.
I know. I told you I'm making it easy.
Question 3.
All right, question 3. Photoelectric smoke alarms are generally more responsive with blank type of fires.
I know
A,
this one.
Grease. B, chemical. C, smoldering. D, flaming. They are not responsive with any of these types of fires. Good luck, everyone. All right, so David has a good question because it did say in there smoke alarms. It didn't say smoke detectors. So I would imagine this is like in a home situation with being a single station smoke alarm.
I'm going 2 for 3 tonight. I know the answer is this one.
All right.
I'm not telling anybody. I'm waiting for everybody to answer. All
right, so David says C. Facebook user, thanks for joining us. We have C.
That's right. That's right. It's smoldering.
Oh, and James goes 2 for 3 tonight and actually redeems himself. And, oh, man, I couldn't even fool you this week. No, that was really awesome. And I told you I was going to make it easy. An easy test, an easy quiz so that you could get some right. And I knew you were going to. So now James is actually 4 for 18. So that's pretty good. I mean, your record went up good. David Englehart has 2 good answers tonight. Facebook user has 2 good answers tonight. So that's awesome. You know,
I actually thought I was answering NEC questions there. The last two. It's like, I got these.
yep. Well, I'll have to work really hard next time to fool you a little bit. I wanted to throw it out there because some of my apprentices, I was asking them some of those questions and they didn't know. So I figured since I already, like made you my fire alarm apprentice and taught you some of this stuff that
I'm realizing I'm better at technical than I am trivia.
true. I'll try to get better trivia next time and
I'm a
trip you up
technical
little.
mind. All right, you
All
ready
right.
for your wall of shame this week? We got the normal picture that has been on that site. So
Did
And
you
I-
get the new song in there?
no, I hadn't done that yet.
Oh, okay, it's cool, but you'll like the new song. It's still the same as this song, but it's just I put shame in there. I threw the
I don't-
shame with the chick ringing the shame bell.
Send it to me again because I didn't see it apparently.
Okay,
And
Yeah,
I'll put
well-
it in for next week.
all right, sounds good.
Here we go.
All right, so this is the infamous Wall of Shame picture. I found this. I was on a service call to a greenhouse, and they said they had like a contactor chattering, and I started just looking around, and I was like, oh my goodness, this is way crazy over here. I would say in this picture at least probably 6 code violations that I could name. With the unused openings not being sealed in the switch, to the probably not correctly spliced conductors coming off the plug, to the incorrect cord cap with a 3-wire adapter.
Yeah, I was
to
going to say,
the-
there's adapters there, aren't there? Yeah.
Yeah.
Wow, that's state of the art, baby.
I know.
Man.
And it was funny because they were like, hey, can you fix the contactor? And I was like, yeah, I'll get the bulldozer right.
I had to give them high marks for making everything work. God dang.
Yeah, and some of the stuff people wouldn't think is like those offset nipples are really not listed to be used like that.
No.
An offset nipple is listed to be used with RMC, and so that's not listed to be used with lock nuts. That's like total state of the art support with
Wow.
with that THHN coming over and grabbing it.
I like the 90 that's coming in. It's like got an upward swing on it.
Oh yeah, they use a little bit over a radius on there.
Yeah. That's
mean,
funny.
Like when I saw this, I was like, "Oh, this is wall of shame worthy." To me, I don't understand. So on the other side of that wall is a refrigerator. So I don't understand how they got that cord through there to that refrigerator. Like they obviously did. They obviously had to take the refrigerator apart and push the cord back through, and then put the refrigerator back together or something.
Wow.
Because I don't know how they got that cable through there. Got that.
He said, hold my beer. Yeah, I agree.
Yeah, so yeah, David, the offset nipples are actually listed for RMC, so they're listed to thread into something. So like you could use that offset nipple if you thread into a Myers hub and thread into RMC. I could do a little bit more research on that, but the last I knew, the offset nipples like that were only investigated to thread into other fittings. So, like when you put lock rings on there, then you're actually you're not using it as it was listed. I could do some more research on that, I've heard a lot of people argue with me about that, and here comes Daniel J, our champion. Uh, yeah, that's a good point. We wondered that too, Daniel. Like, what did they use that rail spike for? You know, like it was to like turn something off or poke something, or who knows? I don't know. It was in a greenhouse. Maybe they were like poking holes in the soil or something. I don't know. But they had some interesting things in there. I mean, I just was totally blown away with the way they taped up that cord end. Like they're like, oh, we could just put a cord end on THHN. You know?
I think they added the rail spike just to make it look more impressive because they knew somebody would take a picture of it.
True. Yeah. Yeah, and I will do some more research, David, but I'm pretty sure that those offset nipples are not listed for use with a lock ring. So, like when you and we run into this all the time, just so everyone knows, like kind of our arguments with this. So if you have like an EMT connector and you're going into a bell box, those threads aren't matching. Bell box is only listed for RMC. So yeah, you could take that offset nipple right into a bell box and then go to RMC. You know, that's what it's basically designed for. A lot of times where we see those offset nipples used is where you go into those meter housings and you come into a Myers hub and then you thread your RMC coming in for your mast.
I
And
think y'all are just being a little hard on the guy. He put a lot of ingenuity into making all that work.
Dude, it's funny because the guy from the greenhouse, he saw me take this picture and he's like, "What are you gonna use that for?" I was like, "Oh, I'll use it." He was like, "I don't know who did that." I was like, "I don't either," but I mean, to get that cord through that block wall like that, that's using some skill right there. I mean, that is like hack times 9 right there. I mean, you worked hard to get that cord through that wall.
Like I said, he put a lot of ingenuity into that.
Yeah.
That's a good illustration. I enjoyed that one. That was all right.
Yeah. So, how about next week? You pick one,
Okay, I can
and
do
then
that.
we'll do the one that you want to do next week, and let's see if you could up me and get more code violations.
Well, I can tell you, after I get off this, I don't know if y'all can see my eyes. They're swollen. I haven't been asleep since yesterday. I woke up at 8 o'clock and I haven't been asleep since then. I had stuff I had to get done. I'm freaking tired.
Yeah, David. I do have stuff saved on that. They are making those offset nipples with combinations. So they must have had some new product released where they actually. I've seen a lot of new products out there where they have both thread types. They're basically called a universal. So they can take a lock ring or thread into RMC. So I'm noticing a lot more stuff like that. Like they're doing universal strut straps to where you don't have to do the TW or the standard anymore. I'm noticing like a lot of more universal parts out there. So that's really good for the industry. And as long as they're investigated for that, you can use it like that. But I agree with you, David. We run into it. I'll have to show you some of the stuff. Like I actually have one. If you have like an EMT connector, that's only listed for use with a lock ring. It's not listed to thread into anything. So then you have the other thing we run into where you have a GRC coupling. Well, that's been Willie Jackerson's transition fitting since his days at Blockbuster, with his do-it-yourself videos, But technically that GRC coupling, that rigid coupling, is only good for one use, and that's threading pipe together. It's not used for taking a seal tight connector and connecting it with the EMT connector. So a lot of people do that and they get away with it, but technically it's a listing violation. It's not been investigated for that use.
Before we get out of here, hey Jace, Thanks for sending me a message over on LinkedIn. I appreciate what you said, brother, about the training that we did on the 70E. And he actually used our generator transform motor compressor book when he was learning the theory portion. And
Oh, nice.
He said he really enjoyed it, and Dad and I were great teachers. So I appreciate you saying that.
I second your opinion, sir. No, thanks for everyone joining tonight. Really appreciate it. We had so many people jumping in, and really appreciate. I don't know who Facebook user is, but appreciate you jumping in. Facebook user had one that was kind of a long thing, and I didn't post it up here because it was on 110.26.
Measures only apply once to reach the equipment, not the entrance and egress. Versus 110.26. How wide or for how big of a person does the access egress path have to be? What is it?
So typically that's 30 inches.
Well, I'm not sure. Are you asking the egress in front of equipment? That's 30 inches wide. Now, I'm not sure if he's asking about the entrance and egress to a room that's locked and tagged out. That's a different thing. And I think that's 24 inches by 6.5 foot. I think that's what it is. It's been a while since I looked at it, but I think that's right. So I'm not sure which one he's asking there. But the width, when you're working on equipment, you have to have at least 30-inch wide space. Okay. And then you got to have a minimum of 3 foot in front of it. Then you look at your conditions and your voltage levels and conditions to where that can change based on voltage and condition.
Okay.
But I think that's right. I think the door, I think it's 24 inches by 6.5 foot.
So the path, that is sufficient size.
Well, it depends. You go into an electrical room, do you have equipment opposite of each other? Okay. You may be looking at that where you have a bigger distance. But, you know, the one thing you have to remember, if you have an arc flash or something, you got to look at it. Can I get out of that area? If you can't, then you've got to double the space.
Okay, once you reach the equipment.
Well, once you reach the equipment, you just it doesn't matter where you are in the electrical room. You've got to have at least 3 foot in front of the equipment. Then you start looking at your conditions. And the only time that condition's going to double in space is if you have an arc and you can't get out of the room because you don't have another pathway to get away from that arc. So
so less than 800 amps.
Yeah, that's what I was saying, and that's that the entrance and egress is based on the entrance when you're coming in the room. That has nothing to do once you get inside the room. That's all based on the equipment.
Right. Okay. Gotcha.
Okay.
Awesome.
And
thanks
matter of fact,
for joining.
we used to do a thing with NFPA, and we had this exercise problem where we had all this different equipment, and we did 2 different ones. We'd say if there was an arc here, and we'd give different voltages for different type of equipment. If an arc happened here, what would be the clearance you'd have to get out of there? Well, you only had one entrance, okay? And it was all run down this way. Well, if you're working on the end down here and you got to go over here, you can't get out of there, okay, without getting into the arc. So therefore, you'd have to double the space. Now, if I had a piece of equipment, but yet I could go around the back of the equipment and come out, then that one entrance is okay. But if you didn't have the clearance, now you got to have 2 entrances into that area in case an arc happened. Gotcha. And then you got to have panic hardware on the door also.
True.
Okay.
All right. Oh,
yeah.
Sufficient.
Yeah, that's what I'm saying. Sufficient, and that's based on what's in front of the equipment. And that's why I say you could have equipment opposite of each other, or you could have equipment and a grounded wall opposite of it. You see what I'm saying? So it depends on the conditions that are there and the voltage level to what that clearance has to be.
If I figure out I can't get the keg out of there, I'm going to do my stop work authority.
Hey, you take some of them older installations, back up until I think it was 71 code or 75, the clearance used to be 2 foot 6 inches minimum. It wasn't even 3 foot.
Wow.
Mm-hmm.
Wow.
All
That's
right,
awesome.
let's wrap it up.
Well,
I'm tired, brother.
Yeah. Thanks for everyone joining. I really appreciate everyone jumping in the chat. I had a great time trying to fool James. I'm glad that I made it easy for you this week, and now you know I was trying to make it easy. So
I had
awesome.
a good time.
Yeah,
Even though I'm tired.
I love these every week. These are so awesome, and we will have a dummies back up right after I get off here. But
I hope so.
I really appreciate everyone joining tonight, and remember, make every day an easy day.
That's right. Everybody have a good weekend. We'll see y'all next week.